This will be a fast run-through of how we want to align our study practices with brain function. Here we see a cross-section through the human brain, and we have the hippocampus here, and we have a section of the cerebral cortex. These would be all the neuron cell bodies, and the white matter would be the axons. First, the key to learning anything is we must be paying attention. What does attention do? Well, attention makes it so that the cortical neurons processing the learning event are more excitable. It's like turning up the volume so that for whatever input is being processed by that cortical region, we get more electrical activity in those neurons. So there's stronger neural activation both in the cortex and, as a consequence of that, down in the hippocampus as well. And if you have more neural activation, you're going to be making the strongest possible memory traces, both in the cortex and in the hippocampus. We also want to be using deep processing study techniques. And again, similar to attention, the deeper processing techniques will have the effect of making stronger memory traces in the cortex and in the hippocampus. Now, why is that? Because deep processing techniques are activating more widespread areas of the brain and or activating them more intensely and or activating them for a longer duration of time. And that all results in stronger hippocampal memory traces. So now that we've done some good studying during the day, we're going to go to sleep. And it's during sleep that our brain undergoes this all-important process called memory consolidation. The purpose of memory consolidation is to strengthen those cortical memory traces. And the brain does so by reactivating the hippocampal memory traces. We sometimes call that hippocampal replay. And these hippocampal memory traces then, when they're activated, they will be stimulating those cortical memory traces to strengthen. We used an analogy of printing. It's like the hippocampus is printing, applying more ink, strengthening those cortical memory traces. So during memory consolidation, we're integrating the day's learning into the long-term memory system. And of course, it's up here in the cortex where we can store a lifetime of memories. Now, why do we consolidate memories in the cortex? Well, for one, let's take a look at the number of neurons. There's an estimate of around 50 million neurons in the hippocampus and something like 16 billion neurons in the cortex. So we just have more neurons and more synapses. There's more storage capacity. So the cortex is a large memory capacity system like the hard drive of a computer, and the hippocampus, having far fewer neurons, is just a smaller memory capacity. There are a limited number of neurons and synapses. So as we learn things during the day, these synapses, the ones that get strengthened for any particular learning event, they cannot be strengthened anymore for further learning. So the storage space for new memory traces has been reduced. So as we go through the day, we're sort of filling up our hippocampus with memory traces of the day's learning. But there's a limitation because the hippocampus is a small structure with fewer neurons. And this then would be a major reason why we're doing this consolidation. We need to get the information stored in the large capacity long-term memory system. Now, there's another reason we do this memory consolidation during sleep. Of course, we want to keep the memory traces that we strengthen up there in the cortex. But because the hippocampus is such a limited capacity memory system, we're going to then erase the memory traces in the hippocampus. So we better have consolidated the memories in the cortex before we do this erasing. So again, up in the cortex, we have neurons that once we make them nice and strong, those synapses are strong, there is slow decay. And that is a feature of a long-term system. We want to be maintaining our memory traces in the cortex. But that's not the case for the hippocampus. We actually want to go ahead and weaken those synapses again, because that's going to prepare them to learn information the next day. So we would say the memory traces in the hippocampus have fast decay. And again, the idea is to reset the hippocampus back to a condition where all the synapses are relatively weak so they can be strengthened again for new learning. So this leads to an important conclusion. We want to study when the hippocampus is refreshed, and that's going to happen after sleep. In addition, we want to repeat our study sessions. Now, while we said there was slow decay in the cortex, there's slow learning as well in the cortex. And here we see a series of synapses here. And the idea is we have to study repeatedly because these cortical neurons have lower plasticity than hippocampal neurons. We've got to activate these cortical neurons multiple times to grow strong synapses. But once we do, they will decay slowly. And by contrast, the hippocampal neurons show high plasticity. They can make strong synapses after one learning event, and that makes the hippocampus a fast learning system. Now, let's reiterate why it's important to repeat our study sessions. We said that there's low plasticity neurons in the cortex. They need multiple activations. Now, if we do our study sessions each day with sleep in between, then we get a situation like this over here with this brain. So here's our first study session. We make a good strong hippocampal memory trace, and we then strengthen during sleep. We strengthen the cortical memory traces. But if then we study the next day, we're going to make a fresh new hippocampal memory trace that will be used that night to strengthen the very same cortical memory traces. And we study a third time. Notice what's happening. If we repeatedly study, we can increase the strength of those cortical memory traces. And that's the value of repeating our study sessions. And we have to do it because the cortex has lower plasticity neurons. Of course, we also want to avoid cramming, because if we only study once, we're going to be left with relatively weak synapses and weak memory traces in the cerebral cortex. And as a consequence of that, we're going to have fast forgetting. We also want to use short study sessions. And now we'll turn our attention back to the hippocampus. The hippocampus is a fast learner by day to be a teacher at night, but that feature of being a fast learner imposes limits on our study practices. We want to use short study sessions. Why is this? Because continuing a long study session leads to synapse saturation and little gain in learning. Because these are such high plasticity neurons, they increase their synapse strength early in the learning session. So if we just prolong our study session, these synapses cannot be increased anymore. So we're sort of wasting our time with longer and longer study sessions. So the idea is that continuing a long study session activates the same hippocampal memory traces. It's much better to take a break, because then it's more likely that we can recruit different hippocampal neurons to make the memory trace for the second study session. So we don't want to just keep activating the same hippocampal neurons because they've already strengthened their synapses. We want to take a break, and when we come back for a second study session, then we'll have a better chance of recruiting fresh neurons. So those fresher hippocampal neurons have synapses that are more capable of new growth to represent the learning in the second study session. Finally, let's take a look at retrieval practice. You'll recall that when we retrieve a memory, we want to use our cortical retrieval systems to reactivate the cortical memory traces, the desired information that we want to retrieve. Well, these are called retrieval pathways. The brain's search system has to physically locate and reactivate the stored memory traces. Well, retrieval practice is just the kind of thing to strengthen those retrieval pathways. In addition, when we activate those cortical memory traces, a new hippocampal memory trace will be formed. And as a consequence of that, when we go to sleep that night, we're going to do memory consolidation again, strengthening those very same cortical memory traces that we retrieved that day. So retrieval practice prevents both forms of forgetting. You'll recall there's two kinds of forgetting: storage failure, where we make weak memory traces. Well, every time we retrieve a memory, we're strengthening the cortical memory traces. So retrieval practice prevents the storage failure problem, but in addition, it prevents the loss of access problem. So we can have strong memory traces, but if we don't retrieve that information for a long period of time, our search system can lose access to the memory. Well, retrieval practice prevents that. Retrieval practice will maintain strong retrieval pathways so we can always find our strong cortical memory traces. So here's the summary. We need to pay attention so we can make the strongest memory traces in the cortex and the hippocampus. We want to use deep processing, again, to make the strongest hippocampal memory traces possible. We want to get quality sleep for consolidation. That's when we're really doing a lot of memory work to strengthen cortical memory traces. We want to have spacing, so we want to space out our study sessions with sleep in between because we want a refreshed hippocampus. We want to repeat our study sessions because the cortical neurons have low plasticity. We need to activate them multiple times to get strong cortical memory traces. We want to avoid cramming because otherwise we'll just have weak cortical memory traces. We want to use short study sessions with breaks because the hippocampal neurons have high plasticity and they strengthen very early in the learning session. So we don't want to prolong our learning sessions. If we must study the day before an assessment, take breaks in between short study sessions. That'll give you the best chance of recruiting fresh hippocampal neurons for the second, third study sessions. And we want to use heavy doses of retrieval practice. Not only does retrieval practice strengthen the retrieval pathways, but it gives the brain another chance to do memory consolidation. Every time we retrieve a memory, we're going to make a new memory trace in the hippocampus that can be used to strengthen the cortical version of that information. But now let's circle back to our diagram about the study cycle. And let's make a couple of important notes. First, during the study session, it's critically important to be paying close attention to what it is you're trying to learn. If you're tired or anxious or distracted in any kind of way, this can negatively affect the quality of the hippocampal memory traces formed during the learning event. So attention is going to be enhancing the strength of the hippocampal memory traces, so that then when we go to sleep, we'll have a better chance of doing memory consolidation. And that brings us to the next point, sleep, and how important it is. It's here. It's during this time when long-term memories are being strengthened by that hippocampal replay. The hippocampal memory traces are reactivated while we're unconscious, and they're signaling and activating the cortical memory traces to strengthen their synapses and strengthen those memory traces in the long-term system. And then also we can see the importance of retrieving memories, not only to test the strength of the cortical memory, so that's giving us metacognition feedback, but every time we retrieve a memory, it creates a new hippocampal memory trace for later use during sleep. So not only does retrieval practice give us good metacognition feedback, but it helps to strengthen the memory traces for the information we're trying to master. And it does so in a better way than just rereading information. And finally, we see why we have to restudy. Why must we study the same information 2 times, 3 times, 4 times before we really master it? Well, that's because cortical neurons have low plasticity, so they must be repeatedly activated to grow strong synapses. So in summary then, to be the best learners we can be, we're going to want to align our study practices with how the human brain makes a memory. By understanding the encoding stage and storage stage and memory consolidation and what happens when we retrieve a memory, that sheds light on the recommended study procedure. And if we can just manage to do this kind of learning cycle for any of our courses in school, we'll have the best chances of maximizing our performance.